Why life depends on exploding stars. Right now, in this moment, you're holding billions of tiny explosions. You can't see them, you can't feel them, but they're there, in your blood, in your bones, in your skin, in every cell of your body. Explosions that happened billions of years ago, far away in space, creating the very matter that makes you alive. Your body is made of dying stars, not metaphorically, not poetically, literally. The atoms that compose you, the iron that carries oxygen in your blood, the calcium that builds your bones, the carbon that forms the backbone of every molecule in your cells, those atoms were created in the core of stars, and they were scattered across space by stellar explosions. You are made of supernovae, and you can't exist without them. Let me make this intimate. Let me make this real. Let me connect the violence of the universe directly to the biology of your body. Right now, as you read this, your heart is beating. With every heartbeat, your heart pumps blood. That blood is red because of iron. Specifically, iron atoms, billions of them, trillions of them. Iron atoms bound into molecules called hemoglobin. And those iron atoms are picking up oxygen from your lungs and carrying it to your tissues. They're keeping you alive. Those iron atoms came from a supernova. Specifically, they came from a star that exploded. A massive star, probably at least 20 times the mass of our sun, that lived for millions of years, fusing hydrogen into helium in its core. As the star aged, as it burned through its fuel, it began fusing heavier and heavier elements. Helium into carbon, carbon into oxygen, oxygen into silicon, silicon into iron. Iron is where the process stops. Iron is the heaviest element that can be created by normal stellar fusion, because fusing iron doesn't release energy, it consumes energy. Once a star's core is made of iron, the star is in crisis. The core can't support itself. It collapses, and the collapse is catastrophic. In less than a second, the iron core, which was the size of Earth but had the mass of the sun, collapses into a ball of neutrons a few kilometers across. The density is incomprehensible. A teaspoon of neutron star material would weigh billions of tons. The collapse releases energy so violent that it triggers a shockwave that blows apart the entire star. That's a supernova. A stellar explosion so bright that it can outshine an entire galaxy. For a few weeks, a single dying star is brighter than billions of living stars. And in that explosion, in that incomprehensible violence, the iron core is shattered. Iron atoms are scattered across space, trillions of them, billions of trillions, spread across light years, mixed with other elements, carried on shock waves. For millions of years, those atoms drifted through space, part of a nebula, part of the interstellar medium, invisible, silent, waiting. And then, about 4.5 billion years ago, in a region of space about 50 light years from where that supernova occurred, something happened. A cloud of gas and dust, including those iron atoms, began to collapse. The collapse was probably triggered by the shock wave from another nearby supernova. The cloud collapsed, and as it collapsed, it heated up. It began to rotate, and in the center, a star formed. Our sun. The iron atoms that had drifted through space for billions of years were incorporated into the solar system. Some fell into the sun. Some were captured in the protoplanetary disk, the cloud of dust and gas orbiting the newborn sun. And eventually, some of those iron atoms fell into a protoplanet Earth. Earth's core is made largely of iron from that supernova. Iron that was created billions of years ago inside a star scattered by an explosion, drifted through space, and eventually became the core of our world. And some of that iron, a tiny fraction of Earth's iron, eventually became part of the rock and water on Earth's surface. And when life began billions of years ago, when the first simple organisms emerged in Earth's oceans, those organisms incorporated iron into their chemistry. And all life has been using that stellar iron ever since. The iron in your blood came from that ancient supernova, the exact atoms, not similar atoms, not atoms of the same element, the actual atoms, created in a star that died long before Earth existed, scattered across space, incorporated into our planet, incorporated into life, and now flowing through your veins, carrying oxygen, keeping you alive. You are made of a dead star. But it's not just iron. The calcium in your bones came from a star. Calcium is created in the cores of massive stars through the fusion of lighter elements. And when the star explodes, the calcium is scattered. Billions of years of drifting and then incorporation into Earth and then into life and now into your skeleton. When you break a bone, when your body repairs it, it's using calcium from a stellar explosion. When your teeth form, when your nails grow, when your muscles contract, calcium is involved. And that calcium came from a dying star. The phosphorus in your DNA, the genetic material that defines who you are, that came from a star too. The sulfur in your proteins, the magnesium in your chlorophyll, if you're a plant, or in the proteins of your muscles, if you're an animal. All of it came from stars. All of it was created in stellar cores. All of it was scattered by explosions. And the carbon. The carbon is the most essential element for life. It forms the backbone of every organic molecule. Every protein, every carbohydrate, every lipid, every nucleic acid. Life is carbon-based because carbon is versatile. It can form 4 stable bonds. It can create complex structures. But carbon doesn't come from supernovae. Carbon comes from something else. Carbon is created in stars too, but through a different process. In the cores of older stars, lighter elements are fused, and in some cases, the fusion produces carbon, but the primary source of the carbon in your body came from red giant stars. Stars that have finished their main fusion cycle and have expanded into enormous bodies. The red giants shed their outer layers through stellar winds, powerful streams of gas flowing out from the star. Those stellar winds carry carbon and other elements into space. And when enough red giants shed their material, when enough carbon is scattered into the interstellar medium, it becomes available for new stars and planets to form, for life to use. But here's what makes this even more profound. Not all elements in your body come from stellar explosions. Some come from the Big Bang itself. Hydrogen and helium were created in the first moments of the universe, and those elements still exist. They're still the most abundant elements in the cosmos, but everything else, everything heavier than helium, was created in stars. Iron, oxygen, nitrogen, sulfur, phosphorus, calcium, magnesium, all of it came from stars. And most of the heavier elements came from supernovae specifically, because only a supernova is violent enough to create and scatter the heaviest elements, which means your body is a graveyard of stars. You're made of the ashes of stellar explosions. You're made of violence and catastrophe, and that violence is essential. Let me show you why. If the universe contained only hydrogen and helium, if there had never been any stars, if there had never been any supernovae, the universe would be completely lifeless. There would be no iron for blood, no calcium for bones, no carbon for DNA, no oxygen for water. There would be nothing. Elements heavier than helium didn't exist at the beginning of the universe. They had to be created. And they could only be created in stars, in the intense pressure and heat of stellar cores, and they could only be scattered into space by stellar explosions. Without supernovae, the universe would be a universe of only hydrogen and helium, no planets, no life, nothing but the most basic elements forever and ever. But supernovae happened. Stars formed, stars died in violent explosions, and in those explosions, new elements were created. Those elements were scattered. And when later generations of stars formed, those new stars incorporated the heavier elements. and planets formed around those stars. And life began on those planets. Life depends on stellar violence. But here's what's genuinely disturbing. The supernova that created the iron in your blood happened billions of years ago. That star lived for millions of years. Fused elements in its core collapsed, exploded, and scattered its material. And we can calculate roughly when that happened. We can estimate the location. We can almost pinpoint the event that created your body. Somewhere in space, billions of years ago, a star exploded. And from that explosion, the matter that would eventually become you was scattered across space. You are not a person. You are a collection of debris from that explosion, organized into a pattern complex enough to be conscious, to think, to feel, to wonder about your origins. You are a supernova that learned to think about itself. And the calcium in your bones came from a different supernova. The phosphorus in your DNA came from another star. The oxygen you breathe came from a red giant. The nitrogen in your proteins came from yet another star. Your body is made of multiple explosions, multiple stellar deaths, multiple catastrophes scattered across space and time, all of it organized into a single conscious being. You are a graveyard, a museum of stellar death, a collection of the universe's most violent events arranged into flesh and blood and bone. But it goes deeper than that. Because the exact atoms that make up your body, not just atoms of the same element, but the actual atoms, have histories. Histories that predate Earth, histories that predate the sun, histories that go back billions of years. The iron atom in one of your red blood cells might have spent 1,000,000 years drifting through space after the supernova. Then it was part of the solar nebula for another 1,000,000 years. Then it was part of Earth for billions of years. Then it was part of various organisms, bacteria, plants, animals, and now it's part of you. That atom has a timeline, a journey, a story that spans billions of years and multiple deaths, and you contain trillions of such atoms, trillions of timelines, trillions of journeys, all converged into this moment, this body, this consciousness. You are impossibly improbable. You are a miraculous organization of ancient matter. You are a temporary arrangement of atoms that have been through supernovae and planetary formation and evolution, and now human civilization. And you will not last. In a few decades, maybe a century, you will die. Your body will decay. Those atoms, the iron from the supernova, the calcium from the red giant, the carbon from elsewhere will be released. They'll return to the environment. They'll be taken up by other organisms. They'll be used to build other bodies, and they'll continue their journey. Long after humans are extinct, long after Earth is destroyed, those atoms will still be circulating through the cosmos. They might be incorporated into new planets, new stars, new life forms we can't even imagine. You're not using those atoms, you're borrowing them. For a brief moment in cosmic history, you're organizing them into consciousness, and then you'll release them, and they'll go on to organize themselves into something else. You're a brief pattern in an eternal dance. But here's what should make you feel simultaneously insignificant and essential. Life anywhere in the universe depends on this. Life depends on supernova. Life depends on stellar violence. Life depends on stars dying so that new stars can form with the heavier elements necessary for biology. This isn't unique to Earth. This isn't unique to our solar system. Any planet that hosts life anywhere in the universe would be built from the products of ancient stellar transformations. Any conscious species would owe its existence to generations of stars that lived, changed, and reshaped the cosmos. Any intelligence would be contemplating a universe that forged the ingredients for its existence through extraordinary cosmic processes. Intelligence is made possible by stellar evolution, Consciousness is built from material created inside stars. Thought itself depends on elements that did not exist in the early universe. The cosmos had to transform itself before life could emerge. And here comes the realization that may be the most profound of all. We don't know whether every universe works this way. Some theories, including aspects of string theory and multiverse models, suggest there may be other universes with different physical laws, different constants, different rules governing matter and energy. In some of those hypothetical universes, stars might evolve differently. The conditions that produce heavy elements might never occur. And if those elements never form, complex chemistry may never emerge, because life, as far as we understand it, depends on elements heavier than hydrogen and helium, carbon, oxygen, nitrogen, phosphorus, iron, the ingredients of biology, the building blocks of planets, the architecture of living systems. Without stellar transformation, those ingredients may never become available, which means intelligence itself could be deeply connected to a universe capable of creating complexity through generations of stellar evolution. We may live in a cosmos where awareness becomes possible because stars continually reshape and enrich their surroundings. That possibility changes how we think about ourselves. You are here because countless stars existed before the sun. Not just one star, many stars. Many generations of stellar activity unfolding across billions of years and vast distances, all contributing material that eventually became planets, oceans, atmospheres, and living organisms. And when you look at your hand, when you see flesh, blood, and bone, you're looking at a record of cosmic history, a story written in atoms. The carbon in your cells was forged in stars. The oxygen you breathe was created in stellar interiors. The calcium in your bones and the iron in your blood were assembled through processes that unfolded long before Earth existed. Every cell in your body carries that history. Every thought you have depends on elements created during the universe's long journey from simplicity to complexity. Every emotion, every memory, every idea emerges from matter that once existed inside stars. You are not separate from the cosmos. You are not merely an observer standing outside it. You are one expression of it. A collection of atoms assembled into awareness, a way for the universe to examine its own history. And perhaps that's the most extraordinary realization of all. The stars did not simply illuminate the cosmos. They created the conditions that allowed the cosmos to become aware of itself.